Hello everyone. In this video, we're going to be solving a nice exponential equation. We have 2 times x to the power 2x equals 1, and we're going to be solving for x values. Now, before we start solving this problem, I want to make one thing clear. This expression is not meant to be the quantity 2x to the power 2x equals 1. Because in that case, the base would be 2x and the exponent would also be 2x, right? And you probably would know the answer. 2x would be 1, x would be 1/2. But this is different. Notice that order of operations dictates that we do the exponentiation first and then we multiply by 2. So that's how we're going to treat this problem. Okay, so in order to simplify this a little bit, let's go ahead and divide both sides by 2. That gives us x to the power 2x equals 1/2. Now, is there a way to make the exponent and the base the same so that we can get something like x to the power x? We'll take a look into that. But first of all, one of the things you can do is x to the power 2x can be written as x to the power x squared, right? Because the exponents are multiplied in that case. So we can kind of write it like this, and then maybe split it up into 2 cases. Because there are 2 numbers whose square equals 1/2, right? What are those numbers? One of them is the square root of 1/2, and the other one is the opposite of that, right? There are 2 numbers whose square equals a non-zero number. Well, I should probably say a positive number, because it's supposed to be positive if we're dealing with real numbers. If you're dealing with complex numbers, that's a different story, and I do have a channel for that, which is called aplusbi. That channel is all about complex numbers. Go ahead and check it out. So, what are we getting from here? We're getting 2 different equations, but we have to be careful. Can x to the power x be negative? Do you know what x to the power x looks like? Do you know the graph of it? Well, we've done that graph quite a few times, so hopefully you'll remember. And I even used it for proving that 0 to the power 0 is equal to 1. You're like, what? Are you serious? It's not 1, it's 0 or undefined, indeterminate, whatever. I can hear you say those things. But go ahead and check out a video that I made on 0 to the power 0. Hopefully you'll be convinced, okay? And let's discuss that in the comment section. So when you graph y equals x to the power x, it kind of looks like this. But that's not an open dot, that's a closed dot, okay? Because 0 to the power 0 is 1. At least that's what I believe. All right, so now notice that x to the power x cannot be negative. I mean, there's no way, right? You can have a negative base and a negative exponent, but that's really kind of crazy and all over the place, because think about it. Suppose you had something like negative 2 to the power negative 2. That would be positive because 2 is even, right? But what about negative 3 to the power negative 3? Yeah, that would be negative because you're cubing a negative number. But it's kind of like numbers are scattered and they kind of jump up and down. So in other words, there's a lot of discontinuities. That's the problem. But now here we get a nice, continuous, smooth graph. That's what's good about restricting the domain to non-negative numbers. Anyways, you can see that the second equation is not going to work, so we have to use the first one. Can we solve that equation? That's a good question. Let's go ahead and take a look. First of all, how do you find the number x that would give you this? What is the square root of 1/2? Well, 1/2 is about 0.5. If you think about it, this is the square root of 0.5. And if you square 0.7, you get 0.49, right? So the square root of 0.5 is definitely greater than 0.7, but it's close. So we are kind of looking at a y value that is less than 1. And that's important because this is where y equals 1 lives. So 0.7 is going to be a little below that. And by the way, there's a minimum value which you can find by differentiation. But let me tell you that 0, what is that called? Square root of 0.5 is going to be something like this. Okay? Great. So wait a minute. There's two intersection points. Yes, there must be two solutions. So we have to be careful. We need to make sure we find two solutions. Okay? Let's take a look. So how do we solve it? We have x to the power x equals square root of 1/2, which can be written as square root of 1 divided by square root of 2, which can be written as 1 over square root of 2, which can be written as square root of 2 over 2. So here's the million-dollar question. Can we solve for x? Is there a function that gives us the solution? So here's one thing you can do. Whenever you get something like x to the power x, you can natural log both sides. Okay? That brings the x down. You get x ln x. And on the right-hand side, you get something like this, which could probably be written in so many different ways, such as we could write it as ln 1/2 to the power 1/2. And then we can kind of bring this to the front. Uh-oh. That kind of gave us an idea, didn't it? X ln x can be written as 1/2 ln 1/2. And then by doing the one-to-one correspondence, we can see that, x equals 1/2 works, right? But we know there are two solutions. What is the other one? That's the million-dollar question, right? So if you really wanted to dig a little deeper and use a special type of function, which is Lambert's W, then you would probably write this as ln x times e to the power ln x, and then apply Lambert's W on this, which would give you ln x. Because by definition, Lambert's W function applied to t to the t gives us t, and it's called the product log. You can use Wolfram alpha to evaluate something or w of something numerically. Okay? In which case you would do this one. But again, you don't need it because we have the one-to-one correspondence, so it would work well. Okay? Easily. But the problem is we must find the other solution. And how do we find that? Let me tell you. So here's how we can go about it. This is a very special equation, by the way, because it allows for two good solutions. I mean, obviously there are infinitely many values of y for which there are two solutions, but only one of them is going to be nice. By the way, I could probably say there's another one which is debatable, but if you think about x to the power x equals 1, you realize that, okay, 1 is a solution, but 0 is also a solution. Why? Because 0 to the power 0 is equal to 1. Again, check it out. See, let me know what you think. Write down in the comment section, okay? So let's go ahead and get back to the second solution. Remember, I was telling you about how to find it. Very easy. Here's what we're going to do. We're going to go ahead and multiply both sides by 1/2. Well, not really. Not multiply both sides. I'm just going to multiply this. I'm going to multiply this by 1/2. Can I? Yes, but you also have to multiply by 2. You can't just multiply by 1/2 because 2 times 1/2 is 1. So yes, you can multiply by 1. That's legit, right? So now what do we get? Here's what you're getting from here. First, we're going to multiply these two things, and that's going to give us 1/4. And then this 2 will be brought over here, and that'll become a power, which will make this 1/2 squared. And guess what? That gives you 1/4 times ln 1/4. And that's just beautiful. You know why? Because again, from one-to-one correspondence, x equals 1/4 works. Yay! There are two solutions, 1/4 and 1/2. And we knew that there were two solutions to this equation, right? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.